Thank you very much. Well, it's a pleasure to be with you again now, and I just need to work out how do I shift? Okay, got it. Okay, so I'm going to talk about Aristotelian causation updated, characterizing why specific things happen in open systems. And I must immediately say I am not an Aristotelian scholar. I rather use his ideas as a basis to jump off and update things in a way which to me makes sense in the light of the way we understand science today. So, how does purpose and agency rise in middle-sized systems? And the basic point which I'm going to talk about, modular hierarchical structures at these scales underlie function. This allows Aristotle's 4 kinds of causation extended, as I've said: efficient causation, which is making things happen; formal causation, causation via shapes or forms; material causation, causation via the nature of matter; and final causation, causation due to purpose. And very important, underneath all of this, stochasticity underlies agency. So, the 4 sections of the talk: the basis of emergence is modular hierarchical structures. Efficient causation occurs at every level.
Can I pause for 1 second? Your respondent has shown up. We need to admit him. Yeah, that's all. Sorry.
Downward causation takes place via formal, material, and final causations. And the really important point, causal closure only takes place when all related levels are taken into account. So, the basis of emergency is modular hierarchical structures, and huge stochasticity occurs at the molecular level. And you saw this yesterday. You have the physics base, you have the basic level of life, the cell, tissues, organs, body systems, organisms, the basic emergent entities of life, where agency occurs, the crucial context of the population, the community, and the ecosystem. And this is the hierarchical structure of life on Earth. Now, why structures? Because that's how function emerges, and biology is all about the interaction between structure and function. Why modular? And the basic principle is you break up a complex task into simpler tasks. You make modules to handle them. You break up the modules into even simpler ones, and you keep on going down until you've got a module which is very, very simple and where you can handle it. Then you merge the outcomes to complete the complex task. And why hierarchical? Because hierarchy naturally emerges on combining the modules. And the details of why this has happened, and it needs abstraction, information, hiding, and other principles, is given in a wonderful book by Grady Booch called Object-Oriented Analysis and Design. And he's a computer scientist. And what one must realize is computer scientists are the people who have constructed incredibly complex systems. And so it's really worth listening to what they have to say. So, here is the hierarchy. At the bottom: particles, atoms, macromolecular chemistry, cells, tissues, physiology, and the level of agency or psychology. And here is a picture from Churchill and Sinofsky in the central nervous system. You have molecules, synapses, neurons, networks, maps, systems, and the central nervous system as a whole. And function takes place at every level. Efficient causation takes place at every level. Synapses work in a certain way, neurons work in a certain way, networks work in a certain way, and you can characterize the functioning at every single one of those levels as effective causation. And the effective causation is different at every level. You use different variables to describe it at every level, different effective laws. Now, key point is the vast numbers underlying biology. The emergence of life arises after vast numbers of atoms and molecules. The number of 10 cells in the human body is 10 to the 13, which I've written out there. It's not obvious. We didn't know that there were cells until relatively recently in the time scale of human understanding. The number of protons in a single cell is 42 million. The number of atoms in a typical cell is 10 to the 14. If you put that together, they're 10 to the 27 atoms in a human being. Now, none of this is remotely obvious, but it is because of this vast numbers that our kind of emergence is possible. And the crucial further point, it's a very, very dynamic context. The oxygen and nitrogen molecules in air at normal room temperature are moving at between 300 to 400 meters a second. A biomolecule undergoes 10 to the 13 tie collisions every second with water molecules. So it's not as if this is all sitting statically. There's this incredible stochasticity and variability. So there's huge stochasticity at the molecular level. And if you want to understand some of this further, there's a wonderful book by Philip Ball just come out called How Life Works, and he talks about biology has discovered the stochasticity and makes good use of it. Biology loves stochasticity and turns it into useful purposes. Now the open systems issue, which I mentioned yesterday, because middle-sized objects are middle-sized, they have an exterior, interior, and closed boundary separating them. Forces impinge on them, that's the green things. Matter, energy, and information enter and leave them. This means that 100% knowledge of the interior state is not sufficient to predict their future, and I emphasized that yesterday. So Laplace's demon for them can never predict their human state. And so if some physicist tells you that Laplace's demon will do it all, and therefore the way the brain works is basically physically trivial, it's simply not true, because the brain has been constructed to take into account that all of this other stuff is going to come in, and it's got to be able to preemptively anticipate and act on the basis of what is probably going to happen. Now, efficient causation occurs at every level, both time-independent and time-dependent versions occur. It's very important that there are static versions and dynamic versions. This takes place by formal and material causation at each level. So, efficient causation is enabled by formal and material causation, and these chain down to affect lower levels. Now, efficient causation, the effects that make things happen, if you like, forces in action. I'm using force in a slightly generalized sense there. It's same level causation, and each of those in the hierarchy, it happens at the same level. It occurs at the underlying physics level, and some of my physics friends say, well, that's all that matters is efficient causation at the physics level, and everything else is just froth on the top of it. But efficient causation is not confined to the physics level. Efficient causation takes place at every level, from the underlying physics level to the psychological and social levels. And Dennis Noble, who is a great physiologist at this university, calls this the principle of biological relativity. Indeed, the existence of efficient causation is what defines emergent levels. If you ask, how do I know what those levels are? The answer is efficient causation is what defines them. They're characterized by specific variables and laws, and incidentally, by particular academic departments, the academic departments that study each of those levels. Now, so let's just look at the psychology, predictive processing, analyzing events, making choices, physiology, pumping blood, enabling breathing, seeing, and so on. Tissues, providing boundaries in terms of our being small things. Our skin is the boundary defining the exterior and interior, and the skin has a lot of very complex properties. Tissues, muscles as an example, contracting enable us to do things. At the cell level, they divide, they transport oxygen, they convey information of their neurons. Macromolecules control ion flows. I'll mention that in a minute. They absorb photons, they're used in signaling. Atoms combine to make molecules, they collide off each other and so on. And particles attract and repel each other. So there's absolutely different kind of efficient causation occurring at each emergent level, described by different laws and different variables. Now, there are both time-independent and time-dependent forms of efficient causation. And as I've said, this takes place by both formal and material causation at that level. And this then involves downward causations to the lower levels. Now, how does downward causation work? And I'm going to discuss this in some detail. Firstly, by setting constraints on lower levels. That's formal causation because it's to do with shapes. Shapes are governed by constraints. And in physics terms, there's a constraint term in the Hamiltonian. And this allows conditional branching, and that's a very important thing which I will mention. Secondly, downward causation takes place by changing the nature of components at the lower levels, which is material causation. And this is a crucial thing in biology. Downward causation creates or alters or deletes lower level elements such as cells, molecules, and so on. This is all affected by what happens across our boundaries. Context alters the outcomes because we are open systems. So this picture, this slide here is a very important one about static and dynamic formal causation. On the left at the top is static causation. It's a glass vessel with water in it, and it's static formal causation because it's the shape of the vase prevents the water running out into the room. The vase shape holds the water in. It causes molecular reversals as indicated on the right of the micro level. So this macro level thing is shaping what happens at the micro level by causing the molecules to reflect back at the boundary, and that's static formal causation. And I'm emphasizing it occurs at the macro level, but it shapes what happens at the micro level, so it's downward causation. On the right is a tap, and at the top it's closed, at the bottom it's open, so that's dynamic formal causation because the constraint changes with time. I turn it on, and I turn it off. When it's closed, the molecules can't get through. When it's open, the molecules get through and drip down. So it's controlling in a downward way what happens at the molecular level. So the macro determines micro in both cases. Now there's material causation involved as well. On the left, it's made of glass. And if it was made of some other material, if it was made of plastic, it wouldn't hold the water in. In fact, it's made of glass as part of what's happening. On the right, it's mainly metal, and again, that metal is impervious to water, and there's also some other stuff in the washer, and so you're seeing here material causation as well. Now, dynamical formal causation in open systems. I've mentioned here the change of shape at the macro level, and another example is closing a switch in a circuit. When you turn the light on, you're making a macro change which changes the macro topology of the circuit at the micro level. It lets electrons flow. This change down to affect dynamics as the micro levels, as I emphasized. Now, you can also get dynamical formal causation at the micro level, where you get a change of shape at the micro level. And this is the foundation of biology, is macromolecules. And macromolecules change shape. It's the discovery of molecular biology, and it allows logic to emerge from the physics. It allows an if-then-else statement to emerge from the physics, and it's this logical branching which is absolutely essential to the emergence of agency and purpose. Now, this is an example of an ion channel, which is a protein, and it controls ion flows across the cell wall. And on the left, the gate is closed because the voltage gradient is upward, as indicated by that arrow on the left-hand side, and so the sodium ions cannot enter into the cell. The cell exterior is above, the cell interior is below, and the ion channel is closed. It's closed because it responds to the voltage across. Now, on the right, the voltage is downward. If you look at plus at the bottom instead of the top, the plus and the minus are inverted on the right, and that causes the gate to open, and then potassium ions can cross from the exterior into. So it is change of shape at the microscopic level, which is the causal agent in this place. And so that is formal causation at the micro level. Now, this enables logic to emerge from the underlying physics, because the logic is if the voltage is upward, then the channel is closed. If the voltage is downward, then the channel is open. And this is how logic, this is one way that logic emerges out of physics. It's via this kind of time-dependent formal causation. It's a key feature, logical branching is a key feature of biology at all levels. There's also material causation. You have to ask yourself, how did these incredible molecules come into existence? And it's the shape of these molecules, but the molecules are material things. And so the question is, how did these molecules come into existence? And of course, they came into existence via Darwinian evolutionary processes, which selected them because they enabled our brains. This happens in our neurons, and it enables spike chains to travel in them, enables us to think, and evolution in effect discovered that we could think if we had these kinds of molecules in our bodies. So this is how that came into existence. Okay. Then you have dynamical material causation in open systems. There are three kinds of dynamic material causation. Creating elements or allowing them to enter the system, maintaining elements when in the system or altering them, and deleting elements or expelling them. And this is material causation in a very important way. The higher levels control what kind of materials exist at the lower level. These can happen at the macro level, so you can create elements at the macro level. For instance, a chemist mixing elements, mixing chemicals in his laboratory produces new things, and then they chain down to lower levels, or they can happen at the micro level alone. In biology, components are structured so as to fulfill higher level purposes, and this can allow logical operations to occur. So, in physics, creating lower level elements for the physicists on the left is Cooper pairs that underlie superconductivity. Now, this is very puzzling. Electrons repel each other, so how can a pair of electrons move as a unit? And the answer is the lattice distorts, and that enables them to occur. And so the Cooper pairs are created by the existence of the lattice. A completely different example on the right is stellar nucleosynthesis. That's a picture of a massive star, a giant red star, and in the insert there's an example of nuclear reactions taking place. It is the structure of the star with the way that the temperatures change with radius, which controls the rate of nuclear reactions and then enables the creation of the elements like nitrogen, oxygen, and neon. And so this is acting down from the scale of the star to the creation of the elements of nitrogen, fluorine, oxygen, and neon, and incidentally, the elements of life out of which we are created. In biology, this is the whole topic of developmental biology. You have different kinds of genes expressed at different places in Drosophila, and then that creates different proteins, and so the proteins are created in order to create this body, and again, this is through evolutionary processes. And so the lower level elements, the proteins, are created by developmental processes and based on positional information. Basically, the context of the developing larva tells the circuits controlling gene expression, which gene should be expressed where, at which place in the body. And so this is creating lower levels in biology, it's creating the proteins which are needed in order to create those parts of the fly at different positions in the fly. Now, maintaining elements, the heart keeps us alive. And again, my colleague Dennis Noble has done a wonderful multi-level computer model of the heart. It's shown on the left, and it shows the top-down effects from the heart to the cell and the gene level that keep the heart level pumping blood. And I won't go into the way that the heart pumps is based through cells and genes and so on. But the point I'm making is this is what keeps us alive. And so this is downward causation from the level of the heart to keeping us alive. If the heart stops pumping, you die within a couple of minutes. And so this is material causation. It's the way that you maintain the cells alive in us by the action of the heart at the physiological level. Now, deleting elements is the core of adaptive selection. Meaningful information is gained by discarding all the information and stuff received that is not meaningful. And conceptually, you've got an ensemble of stuff coming up from the bottom. It goes through a selective gate with some selection criteria, and you get an ordered set of stuff coming out. And you've got the criteria C. If X lies within the criteria, then you keep it. If it's not, you delete it. And the classic example for that is deleting unwanted incoming emails. You select what is meaningful, and you delete the one that you don't. Now, the example of this is natural selection, and this happens in many ways here. The environment basically tells the animal what's good for it, and in this case, this is a polar bear. It's good for it to be white, not black, because then it can creep up on its prey. The animal, metaphorically, tells the animal that it chains down to configure the DNA sequences so that it will produce proteins which will make the fur white. And so it's the environment which acts down to tell the DNA that you should be producing proteins that are going to make the fur white, and that's top-down action creating at the bottom level the proteins which make this bear a successful hunter where it lives. So the selection principle of survival and reproduction is a downward causation. Yes, a different environment. The Canadian forest results in a black or brown bear because it will get different genes. So this is changed material stuff, proteins at the molecular level, and it's a multi-level affair. Each level is selected to enable ecological adaptation. Driving this is ecology, because the bear has to survive in an ecological context. That drives down to shape the genes and the proteins. Now, downward causation takes place by formal, material, and final causation. I basically explained that. What I want to talk about now is multiple realizability is a key aspect of these processes, and final causation is where agency enters, enabled by stochasticity. So multiple realizability, you've got some higher level, and you've got many, many different ways you can realize it at lower levels. Any higher level can be realized in numerous ways at lower levels. For instance, if you have a cell has got an incredibly complicated structure. It doesn't matter the specific atoms where they are. What matters is the atoms are configured in such a way that the cell functions as a cell. And you can shift around the atoms a huge different number of ways and it will still function as a cell. Which lower level realization occurs is immaterial as long as it does what is needed. Billions of molecular configurations will give the desired higher level result. And there's a great book on this by Wagner called Arrival of the Fittest, and he talks about this in the case of the phenotype-genotype maps. Final causation, why? This is the teleological issue of functional purpose, which is the core of life. What's the reason things happen? All life and its component, all evidence has a purpose or function. Staying alive, pumping blood, seeing, walking. In an extended sense, this is final causation, which distinguishes life from physics. Physics, and we discussed this a bit yesterday, a planet, the moon has no purpose. Final causation shapes dynamics at the highest level and thereby entrains lower level efficient causation downwardly. And it requires agency, it requires effective free will. We have this, otherwise iPhones and aircraft wouldn't exist, as I mentioned yesterday. I'm applying a pragmatic philosophy here. What happens at the micro scale is not obvious. But what happens at the macro scales in daily life often is. It is obvious that iPhones exist because we created them. And you don't have to question that in some serious philosophical way. It's just the way things are. And thoughts have consequences. Yes, a lot of what happens in our brains is unconscious, like when driving a car, but some is thoughtful and clearly conscious and has material outcomes. And to claim consciousness is an illusion is a contradictory statement, which I won't go into here. Agency arises in this way from the underlying physics, and this paper by Raymond and Dennis Noble, Can Reasons and Values Influence Action? How might intentional agency work philosophically? And what they say is you harness stochasticity, which can be the basis of creative agency. Such harnessing can resolve the apparent conflict between reductionist micro-level accounts of behavior and behavior's outcome of rational and value-driven macro-level decisions. Neurophysiological processes can instantiate such behavior. The processes involved depend on three features of the organs. They are necessarily open systems. Micro-level systems therefore nest within higher-level systems, and causal interaction must occur across all the boundaries between the levels of organization. The higher levels constrain the dynamics of lower levels. And the highest level is ethics. The choice of purpose and criteria for what are acceptable and desirable shapes build choices at all levels. So levels change down. If your purpose is to kill people through a war, that will change down to your psychology, to what's happening in your physiology, biochemistry, physics, and so on. If your aim is to provide help to people by running the Red Cross or similar organization, that will change down through all those levels and affect what happens at all those levels. Options at the social and psychological level are shaped by what is acceptable and desirable in your viewpoint. These moral values have top down to guide physical outcomes at lower levels. And here ethics is causally effective in the world. This is an example from the war going on between Russia and the others. And you see the starting thing, and you've got this great building, and then what you end up with. So values are causally effective, and you see it in this kind of picture. And the final thing I want to say is causal closure only takes place when all related levels are taken into account. The claim that any physical level by itself is causally closed is simply wrong. And the example I want to give is smoking causes lung cancer. Now, the top level is sociology and economics. Smoking advertising is there for the explicit purpose of trying to persuade you to smoke. And a lot of money goes into that advertising. and there's social pressure. Your friends say, why don't you smoke? And so the topmost level is the sociology and economic levels. This changed down to the psychological level. So you think, I enjoy smoking, and then your rationality says, but maybe it'll be cancer, but then your emotional it says, but anyhow, I enjoy it, so I'm going to go ahead. This changed down to the human physiology level, where it is an established fact that smoking causes cancer. That's a causal relation established by Judeo-Pearl, and that's incontestable. How does that happen? It's because the particles go at the cell biology level called uncontrolled cell duplication. Things take place at the cellular level. How does that happen? Through gene regulatory networks. Protein production based on DNA is altered by the smoke particles. How does that happen? It's through macromolecular chemistry. The regulatory molecules binding conformational changes are what underlies how the gene regulation works. How does that happen? Through quantum chemistry. Molecules bond to create macromolecules which change shape. How does that happen? Atoms bind to molecules. How does that happen? Particles, electrons and protons interact. And the causation chain down from the bottom to the top, enabled by by chaining back up again. Efficient causation takes place at each level. I've indicated that. It's driven in a downward way, starting off with the advertising. You wouldn't be smoking if people hadn't put all that money into that advertising. But it's enabled in an upward way. You can follow the chain up all the way, and you will see how this happens in an upward way. But the whole point is, only the whole set of interacting levels is causally complete. If you omit any level, you don't have a causally complete system. And the statement that the particle physics level is causally complete is simply wrong. It doesn't take into account the context. If I give you Maxwell's equation and say, now what's going to happen? The answer is, it does Maxwell's equations by themselves simply don't cause anything at all. What causes things is this complex context. So, that's back to my summary. How does purpose arise at middle-sized scales? How does biology and agency arise from physics? I've tried to indicate that. Modular hierarchical structures of these scales underlie functions. This allows Aristotle's four kinds of causation extended in the way I've indicated: efficient causation, making things happen; formal causation via shapes or forms; material causation via the nature of matter; and final causation due to purpose, including values specifically; and stochasticity, huge stochasticity, due to this vast number of particles. This wouldn't be possible if we were made of much, much less number of particles. This is the way that it happens.
Oh, yes, sorry.
Yeah, thanks.
And actually, we've realized the problem with the room. If you want to see his presentation, it's probably better to sit back in the other seat. Sorry. Yeah. It's going to be musical chairs.
Especially Val, to say how grateful I am for all to be here. It's a real privilege to be able to interact with folks at this kind of high level. What I'm going to talk about in this talk today is I'm going to lower my guard to some extent. I'm going to share with you some uncertainties and confusions, and hopefully during our discussion you can help me sort this out. My general program, as you know, the last few years has been to try to develop an Aristotelian framework for understanding quantum physics, but also chemistry and thermodynamics as they relate to that. And I'm going to focus mostly on the quantum physics side this morning, and I'm going to lay out, I think you have a handout, right? 7 sort of open questions, as far as I'm concerned, about how one might pursue this kind of program, what sort of directions it might take in the future. So,
That's the wrong.
Sorry?
That's George's.
This is still open. It's still open. This is yours, right?
No,
that's already yours.
So it's options for Q.
It's about you.
Options, Jonathan.
I understand. Rearrange by date modified.
good.
Okay, so now I need to show the screen.
Like you're in charge of this, not me. This is a very complicated dance here. Yeah.
It's so simple, but only a child will use it. Okay, and then that should be ready.
Great. Thanks very much. Yeah. So, just an overview. I'm going to start out just with a few minutes talking about why hylomorphism, but I'm going to give a very short version of that here, and hope that you'll give me the benefit of doubt and say, well, okay, this is worth thinking about further and worth developing. Most of the talk is going to be in the second section, where I'm going to go through these 7 choice points, 7 sort of open questions, and then the conclusion, which will be some very tentative ideas that I have about where to go. So why hylomorphism? So Wilfrid Sellars made this distinction between the manifest image of man, the scientific image of man, and the problem of relating those two. We can make that more specific, I think, by talking about the experimental image, the image of the world we get as an experimental scientist dealing with laboratories, instruments, making observations, and then the more fundamental microphysical or quantum image. And what we've seen with quantum revolution really is that these two images come even further apart than ever before. So in pre-quantum sort of classical physics, there was considerable overlap in both ideology and ontology between the two images. Lots of properties like primary qualities, even things like temperature and so on were shared of two images. But now there's almost no overlap at all, right? Very little overlap between the two. And that creates some real problems in terms of recovering that experimental image. Because obviously if the experimental image is completely illusory or non-existent, then that makes science impossible because it deprives us of the empirical basis for our belief in quantum physics in the first place. So I've been arguing in recent years that the quantum fundamentalist, the one who thinks that all properties that are natural, all natural properties, belong to the quantum image, and therefore all fundamental entities belong to the quantum image. I've been arguing that that program is failing in terms of its accounting for this experimental image. I'm not going to talk too much about that this morning. There is a paper in the Dropbox for yesterday where I discuss, in particular with many worlds interpretation, argue that there's some real difficulties involving the explosion of real worlds that you get that prevents us from being able to say that this world, or a world like the one we're inhabiting, is the one real world at the macroscopic level. So that's one of the real challenges that the fundamentalist has. I also think that so the Oxford Everettians, perhaps Everettians in general, have the strongest, biggest problem here, biggest gap between the quantum image and the experimental image. But I think that other versions too, like GRW and Bohmians, still have a difficulty. That the quantum image of Bohmians, of particles, perhaps featureless particles moving around in space and time, very, very strong non-locality involved. That creates real problems in terms of recovering the experimental image. The GRW's views, either in terms of a peculiar sort of mass matter density idea, or the flash ontology, in both cases, again, there's quite a large gap between that and the experimental image. So there's some reason, I guess, I want to argue here in this first section, some reason for exploring an alternative view in which one takes the view that in the experimental image, in these middle-sized objects, there are fully natural properties, and therefore fundamental entities, and therefore causal interactions that are of fundamental nature, causal powers of fundamental nature at that level. And that, I think, that's basically what I'm calling a hylomorphic or Aristotelian sort of approach to it. Aristotle is the one philosopher from antiquity who takes seriously the fundamentality of the middle-sized world, contrast to Democritus and the atoms of the world on the one side, or Parmenides and the whole universe on the other side. So it's useful, I think, to look at Aristotle as a potential guide here. So, so as I say, there are really several alternatives, I should mention, to a kind of microphysical fundamentalism. One is the pluralism, the hylomorphic kind of pluralism I'm defending, in which some properties of the experimental image are perfectly natural, fundamental properties conferring causal powers, supporting fundamental causal laws. But there are other alternatives, which I know some of you in the room would prefer, versions of dualism or phenomenalism or even idealism. In this case, the additional natural properties and fundamental entities would all be mental in nature. And I think both agree that there's a need for a kind of formal top-down constraint of some kind on the experimental image. So I'm not going to discuss the debate between these two in this talk. I just want to set that out there. My own preferences would be obviously for the pluralistic account. Not that I don't believe in the mental, but that I think having an account of this middle-sized physical world is actually very helpful in developing a more sophisticated kind of emergent dualism ultimately. So, let's see, sorry. So what would the hylomorphic picture look like? Quantum wave function represents a kind of bottom-up material causation for the Aristotelian. And what I'm arguing is that that's not sufficient. In addition to that, there has to be some kind of formal cause from the real essence and the accidents of composite objects. So the presence of substantial forms and of accidents, so both of these things are formal causes in the Aristotelian kind of framework. Excuse me for a second, I want to mess this up. The presence of form and accident in particular places and times has a diachronic explanation in terms of efficient causation. So that forms are generated when the new substance is generated. All accidents are generated through alteration by other objects at that middle level. So there's in potential two versions of this sort of hylomorphism. One could be an imperialist, and one could argue that these kinds of middle-sized properties are the only fundamental ones, and that quantum mechanics is treated instrumentally, anti-realistically. Or you can do it in a more accommodationist way and say that the fundamental properties of the world are both at the quantum level and at the middle-sized level. And that's the first that I'm going to defend this morning. But I think the other one's an interesting option. So how are fundamental laws governing composite objects possible at all? I mean, if there are fundamental laws at the microscopic level, you might think that leaves no room for any kind of fundamental laws or fundamental causation at higher levels. But I think there's at least three cases in which that could happen. The laws at each level, including the quantum level, could be explicitly indeterministic. Even the final probability of an event would be determined by laws or conditions occurring at multiple levels. So all the different levels contribute to the final probabilities. It could be that the quantum laws are only approximately true. You get more and more from actual results as the time and space scales increase. So even if they're explicitly deterministic, they're implicitly or de facto compatible with micro-indeterminism, in which case, again, in option one, the final probabilities can be determined at multiple levels. Or thirdly, the quantum laws might be just local in their application, depending on non-quantal boundary conditions and pre-quantal structuring of the state space. And so now the dynamics of pure quantum mechanics have to be embedded in larger phase space, one defined in terms of extra quantum quantities like those of chemistry and thermodynamics and biology ultimately. And these are not mutually exclusive options. One can combine the two of them in various ways. Okay, so that brings me to the main point of the talk, and that's to go through some of these hylomorphic choice points. What are some of the options? So one that I've struggled with for quite a few years now, and still have not resolved, is what to do about the wave function. Should we posit a cosmic wave function, a wave function that defines the behavior of all the particles of all the substances in the world, right? Is that necessary? There's a pretty strong case to say no here, I think, from a cosmological point of view. Namely, one could argue, as George and Drossel have argued, that quantum mechanics is really only valid for small scales and short time frames. And so if you could construct a cosmic wave function, it would be pretty much useless because it would deviate so far from what actually happens in the world. You could also argue that quantum mechanics is always applied in some sort of concrete context, and the universe doesn't exist within a context, a concrete context anyway, so there's some question about whether it even makes sense to talk about wave function in that sort of setting. One could point out that quantum cosmology, one place where this sort of thing is used, is highly speculative. We haven't derived a lot of, at least in the quantum realm, a lot of observable results. And then finally, this relates maybe to the second point as well. You might, if you think of quantum mechanics as really defining or determining the probabilities of measurement events of some kind, then you might say, well, if there's no way to measure the whole cosmos, there's no way to observe it since we're all part of it. And so those are all recent considerations that push one in the direction of no. But I want to push back a little bit and wonder whether that case is compelling, or perhaps the hylomorphist should, in fact, look at some kind of cosmic wave function. First of all, I'm not really clear, and maybe George and others can help me with this, whether both space and time constraints are needed. So could a cosmic wave function provide accurate predictions, at least for a very short interval of time? And if so, then there would be some reason to do so. Even if it couldn't, model what would happen in a year or a day or even a few minutes. I mean, if it could, for a few nanoseconds at least, tell us something interesting that might be still worth doing. And secondly, is there really an upper bound of the number of particles that can be included in an accurate quantum mechanical model? It seems not, right? Because we do have quantum mechanical explanations for the behavior of macroscopic bodies like supercooled or superconducting bodies, Bose-Einstein condensates, phonons, and so on. So it doesn't seem to be clear that we could say that because quantum mechanics is, even if it is in some sense limited to small-scale objects, it also seems that we can build models that apply to macroscopic objects with many particles, including the whole universe, perhaps. And thirdly, about this context. So does the context that's required for wave collapse require further substances rather than just further natural properties? Right? So, you remember again, for the Aristotelian, the quantum wave function does not exhaust reality. There's more to reality than the quantum wave function. There are also these substances with their natural properties at the middle-sized sort of level. You could certainly conceive of it like a EPR, Einstein sort of thought experiment, where a given substance is both the source of the pair of electrons and also then later acts as one of the detectors of one of the electrons as well. And so in this case, the very same substance would be, in a sense, measuring its result. I mean, you just send one of the electrons in a circuitous route and send it back to the original substance at some point to register it. So couldn't we have a universe where different parts of the universe, or maybe the universe as a whole, sort of measuring itself, so to speak, through these higher level properties, right, beyond the quantum realm. Now, I think from what I understand the Ellis-Russell model, I think that there is this idea that in addition to the system that's being measured, you need a thermal heat bath of some kind, otherwise the measurement can't take place. So that's, I think, an argument in response to my third worry here, which is maybe it is in fact impossible to have a wave collapse of the universe because there could be no external heat bath, right, beyond the universe relative to which it could be resolved. And that, I think, is the most important argument, actually, from their program against the cosmic wave function. But here I sort of put on my philosopher's metaphysical hat, right? And I say, well, wait a minute, couldn't we do a thought experiment where we take what is actually the universe and now embed it in a counterfactual context where there's an additional heat bath up there somewhere? And so we could ask, what would happen in that situation to the universe? And it seems like we should have an answer to the question, what would happen? And to answer that question, you need a wave function, a cosmic wave function, right? Which you can then carry into that. Now, what this, I think, shows me is that the cosmic wave function, if there is such a thing, is only contingently or de facto cosmic. Right? That is, it might be a wave function that applies to the things that are actually the totality of the universe, but they're not de jure cosmic wave function, right? That is not a wave function that belongs to the universe as such, the totality as such. That, I think, these arguments suggest is probably incoherent. But the idea that there might be a de facto wave function of the entire cosmos strikes me as plausible. So I would, at this point, sort of lean in that direction to suppose that that makes sense. Now, you might still worry that the idea of a cosmic wave function is just superfluous. I mean, even if you could model it and make some sense out of it, doesn't have any use. Because suppose entanglement in the universe is very local and temporary, then the cosmic wave function would just be a sum of lots of very local and temporary wave functions. It wouldn't really add any interesting information to us. It wouldn't really promote our understanding in any way. And so this seems to turn on the question of whether the whole universe itself is entangled. So this is another issue that I've been working on, which is, as an Aristotelian, should I think of entanglement as something that happens within a single substance in every case, right? Within the different aspects or different parts of a given substance? And I think there's pretty good reason to think no. In fact, different substances in the Aristotelian world can become entangled via parts, quantum level parts. And this is the European Scholar thought experiments from 1992, where they show how to set up an EPR-like correlation involving two completely independent sources of electrons, so or photons, whatever you're using, right? And as long as you send them along paths through various reflectors, so that the paths of these particles overlap in certain ways, you end up with EPR correlations, even though the original sources are completely independent. So this seems to show that it's quite possible for multiple substances to become entangled with each other, and therefore quite possibly the whole universe, that all the substances in the world are mutually entangled in this way, in which case again you would need a cosmic wave function to represent that massive entanglement. Okay, that brings me to the second choice point, which is should the dynamics be exclusively unitary Schrödinger-like, or should we adopt some sort of objective collapse picture? Right? So if we say no to the first question, right, there's no cosmic wave function, all wave functions are local affairs, or temporary local affairs, then it seems to me that it's a very compelling reason to go with the collapse interpretation, right? To suppose that as the wave function that we're modeling is measured in a relevant sort of way by macroscopic objects, the wave function collapses. But what if we say yes? What if we have a cosmic wave function? Then it seems to me there's both options seem to be available, and I'm not sure which way to go or what the considerations are that would push us one way or the other. We could have an objective collapse of the cosmic wave function, resulting in something like a GRW or Penrose kind of picture. The difference would be that instead of in Penrose and GRW, the collapse itself is a microphysical kind of phenomenon. It just depends on how many particles are entangled or what gravity is doing at the macroscopic level. Whereas an Aristotelian is going to have a kind of top-down objective collapse of some kind, where these middle-sized properties are going to play an irreducible role in explaining the collapses. And maybe we could do something that sort of adapt to modify the Ellis-Strassel account of the classical and thermodynamic features that precipitate the collapse. Again, in a kind of counterfactual, hypothetical sort of way, since there's no actual feedback to do it in this particular case. But we could also go with a no-collapse model. And so it's quite possible, I think, to give a hylomorphic account of the Everett interpretation, or of something like a modal interpretation. So Alex Proust, in his chapter in our book 2018, develops what he calls a traveling forms model, which is basically a modal interpretation that uses Aristotelianism. So the thought here is that you get the privileged observables in a top-down way by looking at these essences and accidents that belong to substances, and those are realized at the quantum level by particular observables, and so that gives you the privileged basis, right? The determinables at the quantum level that are always have some sort of value, ones that correspond to these forms of accidents, right? And then you use some sort of dynamic like the Bouverie Dixon dynamics from 1999. It's a fantastic kind of model for how you can evolve those sorts of determinables in that way. And that's connected to my third choice point, which is whether we should have one world or many. So, as I said, it's possible to combine an ever-ready many worlds interpretation with Aristotle. So one of the great problems that the many worlds people have is how to recover what they call branches, right? So in the quantum formalism itself, there are no branches, there are no worlds, right? There's no three-dimensional objects, splitting apart and so on. So you have to somehow make sense of how you extract that from the quantum wave function. I know this is going to talk about that later, more today, or model how to do that. I think it's a difficulty. Hylomorphism could help, I think, because hylomorphism can appeal to these essences and accidents of middle-sized objects as defining, again, which observables are the ones to look for that will define the real branches, right? So you could go that way. But in fact, I think the one-world option seems preferable. Multiple branches can be considered as really as representing, from an Aristotelian point of view, I think, multiple potentialities. So each branch on this picture would be a kind of potential world, but there'd be one actual world, right? I think that's the key Aristotelian commitment, really, is that there's a distinction here between actual and potential. Aristotelians, in a sense, attempt to abolish that distinction and treat all the potential worlds as equally actual. I think an Aristotelian should resist that, ultimately. And this also gives us a basis for the interpretation of probabilities by something like the Savage axioms. So I've argued that you can't really make sense of the Savage axioms except in a one-world kind of setting, because if you cared about things that were realized in multiple worlds, you would violate the sure thing principle, right? So if I were Rawlsian about all of these alternative worlds, instead of trying to maximize the average, I was just sort of worried about, well, here's a world where, you know, the welfare's going to be really, really low, so I'm going to have to avoid that action. If you start thinking that way, then you won't be able to recover the probabilities, the Bourne probabilities. So I think there's some reason to go with the one world kind of picture, and something like a modal interpretation seems to be like the best way to go there. Fourth choice, should the dynamics be universal? If the dynamics are universal, there's no class. Should we have a deterministic or stochastic dynamics, right? So Bohm's version of his theory has a guidance equation, which was deterministic, right? So all probabilities were just reflecting our ignorance in the Bohmian picture. On the other hand, Bell proposed a stochastic version of Bohmianism, and that's further developed again by Bouverie and Dixon as a more general strategy for the modal interpretation of quantum mechanics. And I think there's good reason to prefer stochastic dynamics over the deterministic one. Here's at least three reasons you can mention. One is an argument that I gave in 2000, that indeterminism can be used to define an intrinsic direction to time and causation. So if you imagine that the future is branching and the past is not branching, that gives you a kind of determinate direction to time, and that kind of branching future fits really nicely with indeterministic kind of dynamics. Indeterminism at the quantum level is necessary if composite objects are to be real difference makers. So avoiding over-determination kind of worries. This goes back to the slide I had earlier. And finally, indeterminism avoids an objectionable form. I think an objectionable form of action at a distance in quantum mechanics. So there's a distinction in the literature, going back to Shimony, between violations of parameter independence, which is bad, according to Shimony and me, and violations of outcome independence, which is okay, again, according to both of us. And to get this sort of to go the right way, you need to have a stochastic rather than a deterministic dynamics. So when is action at a distance problematic? I think it's only problematic when you have what I'm calling positive non-locality versus negative non-locality, which is fine. So a negative non-locality occurs when an event at one location nomonologically entails that something at a space-like separation, so again, far away and you can't get there in time, loses some stochastic causal power that it will otherwise have, right? So in an EPR type experiment, you observe one electron, it's spin up, you now know the other electron has to be spin down, right? All that's happened is that the other electron has now lost a certain power that it had before, the power to go spin up. It can only go spin down, right? It's not able to do something new that it wasn't ever able to do before, so to speak. It always had the capacity to go spin down. Now it's just lost one of its other capacities. Where positive non-locality occurs when an event entails that some space-like separated object gains a new power it didn't have before, or gains some other kind of intrinsic property that it wouldn't have had before, right? And that seems to be an objectionable kind of action at a distance. And the reason for that is not primarily to do with relativity. I mean, I'm not so worried about that, actually. But I'm definitely worried about the epistemology of action at a distance, right? So if you look, again, at something like Nancy Cartwright's models of how scientists learn how things work, you build a nomonological machine, you sort of isolate things from their environment, you pair them up and see what happens when they interact, right? If there's action at distance that's immediate, has no limit on distance, there's no limit on its intensity, so it can be very, very strong influence at a very, very great distance instantaneously, that's going to create epistemological problems, I think, for all of our experiments. How are we ever going to have the confidence that we've successfully isolated things in order to figure out what's going on? Whereas if the non-locality is really negative, there's no problem, because you won't see anything that couldn't have happened. If you see something happen, you'll know that it happened locally, right? That is, there'll be a local explanation for the powers. It's only the things that don't happen, right, that have non-local sort of explanations. That brings me to choice point 5. Is the dynamical law or laws of quantum mechanics grounded? And if so, by what? Right? So scientists generally take for granted that they can explain things in terms of laws of nature. We metaphysicians are not satisfied with that as the final answer, right? What's a law of nature? Why should that explain anything, right? And there are a number of different options here. There's the sort of Humean option. that says the laws of nature are just theorems of the best system of generalizations. I won't go into detail. There's been a lot of dissatisfaction with that account, I think, and I'm certainly one who's been very dissatisfied with it for a long time. You could take subjunctive conditional truths to be fundamental, like Boudewijn does. Again, that seems to a lot of us to be pretty strange. Conditionals are be true by something, it seems. You can take the domic realism of Thule, Gretzky, and Armstrong. So laws are some kind of peculiar metaphysical tie between universals, or Platonic forms of some kind. And then finally, there's the neo-Aristotelian or causal powers of account. So no surprise, I like the fourth account best. It provides a basis for the causal laws. Right? The causal laws are grounded in the essences of substances, and the causal powers of those essences and accidents as well confer upon those powers. So the reason that sort of the law of nature that water boils at 100 degrees centigrade is because it's the nature of water to do that as a causal potentiality that expresses itself in a regular way in that way. The Thule, Gretzky, Armstrong thing, the problem there is how do you get from this peculiar law of nature to real things happening in the world and not happening in the real world, right? I mean, it looks as though you need something like God to be the enforcer of the law of nature, right? And say, no, you can't do that because it's against the law of nature. But then you're back to version 4, actually, because now you're just appealing to the power of God, right, to enforce the laws. So why not just go for a simpler account here and just give the powers directly to the creature? So again, the essence of a substance determines what kinds of powers and accidents and actual parts it could have, and to what collectives it could belong under various circumstances. So what actual powers a substance has depends on its parts, accidents, and memberships it has at the present. So these in turn depend on its history, its past interaction with other substances, and interaction with each other. So there's plenty of room for diachronic bottom-up explanation of this picture. Sometimes when I defend the Aristotelian view, people assume that I'm saying it's all top-down, so there's no bottom-up influence or constraint at all. That's certainly not the case. So Aristotelians should, I think, take the Schrödinger dynamics, the wave function, to be grounded in the essences of the relevant substances. Right? So it's the substances of the world have certain essences. Those are what ground the Schrödinger dynamics. So for contextual quantum mechanics, if there's no cosmic wave function, it seems pretty straightforward. You can say that the contextual wave function is always grounded in the essences and accidents of the substances involved in that particular wave function. Now, in the case of a cosmic wave function, it gets more complicated, I think, because substances come into and go out of existence over time. So which substance is it that ground the wave function, cosmic wave function, at any given point in time? Well, presumably it's the substances that exist then, right, that do that. But then does that mean that the cosmic wave function itself is constantly coming in and out of existence as new substances come online or substances go out of line? And there's a worry here that both Alex Cruz and that William Simpson has pressed, that this kind of story leads to a kind of, either to a dilemma here of, to a sort of dilemma that is either the cosmic wave function and Schrödinger's laws are over-determined, right, determined by the essence of each substance individually, and therefore massively over-determined, or we face the problem how to parcel out responsibility for different parts or aspects of the quantum wave function among the various substances in the world. And that's a non-trivial, it seems to be a pretty non-trivial task. So my suggestion, though, is that we try to address that. So rather than just avoid it. So there's a choice here again between a cosmic substance as the ground of the cosmic wave function or a cosmic group. And so I'm going to press here a kind of analogy with Aristotle's conception of the city. So in a sense, the cosmos is a sort of city, and the substances are citizens within the city. So in the case of the political realm, citizens are substances, right? And cities are not. So cities do not constitute substances. The possibility of the city depends on the essences of individuals. So it's the essence of individual human beings that are driving that possibility. Nevertheless, the citizens of a city are deeply entangled. There's a kind of political entanglement, very similar to the quantum entanglement. You can't give a complete explanation of what's going on in each individual citizen except by referring to the social relations that individual has. And citizens can survive the gain and loss of individual citizens. Cities can survive the gain and loss of individual citizens while still being the same city. So it seems in the same way that one could argue the quantum wave function persists as a kind of joint activity of substances, and it persists even though substances are coming in and out of existence over time. They say it seems to be a possible line to take. Choice point 7 if we did decide that there's a cosmic level substance, so disagree with my view about the cosmic group, face another choice, which is, should we have just that one substance, the whole cosmos, and demote everything else to a non-substantial kind of status? Or does the cosmos coexist somehow with localized substances, right? And so this brings us, Jonathan Schaffer's defended this sort of view of priority monism that really, he doesn't use the substance language, he's not an Aristotelian, but if I were to translate Schaffer into my language, he's basically saying that the cosmos is the one and only substance, right? The only thing that's fundamentally real and everything else is a fragment of the cosmos. Whereas Aristotelians, I think, are going to argue that we want to have these individual things, middle-sized things, these substances, right? So now the question is, can you have them both? Can you have a cosmic substance and individual ones? And there you run into what Schaffer calls the tiling principle, which I think is a very plausible principle, which is that if you look at all the fundamental things in the world, Schaffer argues, they shouldn't overlap with each other. They should be jointly exhausted, but they should be individually disjoint, right? Because after all, if they're fundamental, right, and they overlap, then it looks like that overlap is going to be overdetermined in terms of its nature, right? And if it doesn't exhaust the reality, there's some stuff floating around that has no fundamental basis at all, and that also seems pretty weird. So I think, in fact, Aristotelians should agree with Schaffer here, that some kind of tiling principle is reasonable. So I've got what I call an Aristotelian tiling constraint. Everything is wholly composed at that time of substances, parts or accidents of substances, or remnants of substances, and no substance overlaps any time another substance or a remnant of another substance. Well, I won't go into what remnants are, I've got a paper on that, but the substances can leave remnants behind. But in any case, that principle is still pretty plausible, and it's going to create problems for the view that has both cosmic substance and individual substances, because you might assume, actually, that the individual substances would be parts of the cosmos, and that would violate this tiling constraint, would create these problems of sort of metaphysical overdetermination. It's a bit worrying. Now, what's wrong with cosmic monism? It doesn't fit into, again, I'm a metaphysician, but I often resort to epistemology. So I think one of the main problems with cosmic monism is that it doesn't fit in well with an Aristotelian essentialist epistemology of science, right? So we understand things in Aristotle's view by understanding the essences of substances, right? And that means discovering their real definition. So, but we never study the cosmos as such, right? Because it's a one of a kind by definition, right? So we can't really fit it into a species and then construct a Porphyrian tree of genera and differentia and so on. They're just the one thing, right? And we can't apply a kind of Nancy Cartwright study of the cosmos by putting it into an homological machine and interacting with things with it. So there's something sort of mysterious about the cosmos if it's a fundamental entity, if it's not just a collection of substances that are themselves fundamental. Now, William Simpson has proposed recently a version of this that I think avoids some of my objections. So you could say that actually there are both the cosmic substance and the individual substances, and they don't overlap, right? So in this case, the way William works it out, there's various ways you can do this. The particles are parts of the local substance at the point of creation, and then immediately become parts of, after that, of the cosmic substance. And the particles are constantly being created, so the substances have something to do. They're sort of responsible for these stochastic creation events and annihilation events. One difficulty, we were talking about this with him yesterday, is it does look as though these substances will have a kind of gappy existence, because in between creation events, there will be nothing there, so to speak, except the substance itself. And that resembles sort of the soul in the intermediate state, I guess. So maybe maybe they just combine those two problems in one and resolve them in some way, but it does seem to be a bit difficult.
We'll have to wrap up around a minute.
One more minute? Yeah, I'm good. Just about there. So do we need a cosmic substance? I think it would be anomalous in various ways. It would be an impassable thing outside of space and time, and to me there's a danger here of falling into a kind of Malebranchian occasionalism, where it looks more and more like the cosmic substance is something like God. And then the difficulty is going to be, science would then become literally trying to think God's thoughts after him. God's intentions are pretty opaque most of the time, I think. Much easier to understand if those intentions are realized in a particular substance natures that we can study individually. So I think that's, again, plausible. So I've got this idea of, one last point then before I run out of time. how to divide responsibility. I think if you look at an algebraic kind of approach to quantum mechanics, then it turns out that you can look at the sub-algebras of the algebra of the cosmic wave substance as restricted to some space-time regions, and so that is maybe a natural way to divide responsibility for the wave function among the various individual substances. So anyway, there's my very tentative conclusion. I'll get there.
We will have a short video prepared by Professor Halvorson, and then he's joined us from Princeton live to interact with the two speakers and with all y'all, as some of us used to say. Here is his response. Can you hear it?
I'm grateful for the chance to join you virtually since I couldn't be present in person, and I'm grateful for the chance to comment on these interesting papers by George Ellis and Robert Koons. Let me point out that my comments here will be based on the preprints of these papers, and so there might be a slight mismatch, at least in emphasis, with what you just heard. Ellis and Koons make some strong claims, and claims that go against the grain. It's one thing to take a stand against microphysical reductionism, and quite another thing to tether one's wagon to Aristotle's natural philosophy. But it's the latter course that Ellis and Koons take, and urge us to take. I myself am not convinced that Aristotle was so prophetic in his vision that he could have anticipated the issues that we face today. But I'm not going to bicker about that. For me, and for many of you, I suspect, the most interesting choice point is whether one is going to adopt the program of reducing the manifest image to the scientific image. Ellis and Koons urge us not to adopt this program. They urge us to adopt what may seem like the opposite program. So what is interesting is the arguments they give against the reductionist program. In my comments, I'm going to focus on three strands of argumentation. First, the argument from top-down causation. Second, the argument from elementary quantum mechanics. And third, the argument from the quantum theory of infinite systems. There is no longer any orthodoxy about causation. Some philosophers agree with Bertrand Russell that it is a relic of a bygone age. Other philosophers think that causality does have a role to play, but only really at the fundamental level, which they identify with the microphysical level. There are even philosophers who agree with Russell that causality has no place in fundamental physics, but does have a place in the manifest image of the world. George Ellis has a rather nuanced view of causality. He claims that each level is relatively causally autonomous, in particular has its own causal laws. And yet he claims that no physical level is causally complete. How these two claims hang together is not totally clear to me. But so far the disagreement with a standard reductionist is not that great. A standard reductionist might be willing to grant that, say, the laws of hydrodynamics are relatively autonomous from the laws of microphysics, but that the world of fluid flows is not causally complete. Where Ellis's view is likely to raise the hackles of philosophers is his claim that there's top-down causation. I have many questions about top-down causation, some of which may be answered already in Ellis's other papers, and which I hope he might take the occasion to comment on here. First of all, what is meant by macroscopic constraints controlling micro-level dynamics? Is this just the claim that macroscopic creatures such as ourselves are able to implement micro-level dynamics, for example, to set the Hamiltonian of a certain quantum system? If so, then won't the reductionist just answer that there is no proof of the causal incompleteness of the microphysical, since the microphysical is thought to determine the causal agency of creatures like us? In other places, Ellis hints that certain macroscopic forms play a causally determining role vis-a-vis the microphysical. At one place he mentions macroscopic circuit topology as causally relevant, and yet not reducible to microphysics. Here Ellis is on to an interesting issue that comes up repeatedly in physics, and especially in so-called gauge theories. For example, in the Aharonov-Bohm effect, the microphysical dynamics is also sensitive to the global topology of the underlying phase space. I grant that holism does appear in several places in contemporary physics. However, it's not immediately clear to me that this holism belongs to the macroscopic, in the same sense that medium-sized objects belong to the macroscopic. After all, the phase space, the topology of phase space is not exactly part of the manifest image. I now turn to the second issue, that is Robert Koons on the measurement problem of quantum mechanics. As Koons points out, Heisenberg himself claimed that quantum physics opens the door again to Aristotelian potentia. But is there anything like an argument here? Can we make the theses of Aristotle precise enough so that quantum physics could be taken to provide positive confirmation of these theses? That would be what we might call what Abner Shimoni told us to call experimental metaphysics in the best possible sense. Let's consider the infamous measurement problem in the formulation given by Tim Maudlin as an inconsistency between three claims. First, measurements have outcomes. Second, the wave function is complete. And third, the dynamics is linear, or put even more technically, unitary. This formulation of the measurement problem is slightly different from the one that Koons gives, and we might ask how they're related to each other. Or more importantly, does the Aristotelian have the resources to solve the measurement problem? There are some ambiguities here in the statements, both of Koons and of Ellis. At places, they mention that the microphysical dynamics needs to be stochastic so as to provide room for downward causation. But in that case, they seem to be rejecting the premise of linear or unitary dynamics. And if that is what they are doing, then their move might backfire on them. If they're willing to reject the Schrödinger equation, then why not adopt something like the GRW theory that promises to maintain the causal integrity of the microphysical realm, and which would be a triumph for microphysical reductionism? After all, the GRW theory is a favorite of those who are committed to the microphysical reductionist program. I suspect that Ellis and Koons, upon reflection, would also be troubled by the statement that the wave function is complete. It does sound a lot like some kind of statement of causal completeness. However, in the typical case, rejecting the completeness of the wave function amounts to accepting yet another more microphysical layer of reality, for example, the hidden variables of Boudewijn mechanics. But perhaps, and again I invite them to comment on this, perhaps Ellis and Koons would suggest that the wave function is incomplete in a different sense. But in what sense? Finally, I turn to Koons' interesting invocation of facts from the quantum theory of infinite systems. Here the claims are quite controversial and quite technically daunting. To be honest, I myself would be greatly surprised if the fate of Aristotelian natural philosophy depends, for example, on the mathematics of infinite quantum systems that are beyond esoteric in a certain sense. But nonetheless, it's worth asking what role these considerations are meant to play in Koons' account. I can see two distinct options. First, the quantum theory of infinite systems may be taken to be the solution to the measurement problem. Second, the quantum theory of infinite systems may not be taken to be the solution of the measurement problem, but it might show other ways in which the old mechanical philosophy and microphysical reduction in general is inadequate. I will leave aside the first possibility as it has been argued quite convincingly by others that moving to the infinite limit does not solve the measurement problem. However, what happens at the infinite limit is indeed interesting. Essentially what happens is that a single quantum state space breaks into a plurality called the superselection sectors of the system. And the distinction between these sectors is, in a certain sense, classical. That is, each sector corresponds to a value of a quantity that has no conjugate, as for example, position has momentum as a conjugate, and so this super-selected quantity can be always definite, that is, always have a value. Koons indicates that the distinction between these super-selection sectors is macroscopic. I quote, Two situations can be microphysically indistinguishable and yet chemically and thermodynamically different. End quote. That is certainly true in some cases in quantum thermodynamics, but unfortunately it is not always the case. For example, in quantum field theory, the superselected quantity is itself a microphysical quantity, typically called, in a generic sense, the charge. Nonetheless, I don't think this is a damning point against Koons' use of quantum theory of infinite systems. In fact, it may be a point he can accommodate, namely that non-quantum forms, so for example, the form of the quantity related to superselection sectors, are not necessarily macroscopic forms. In conclusion, Ellis and Koons ask us to bring physics into interaction with the manifest image of the world. That is, to take seriously the call for consistency between theory and appearance. The task, as we've seen, is dauntingly difficult, and I'm grateful for their courage in facing it. Thanks, and I look forward to the discussion.
George, for the discussion, if you're here, then Professor Halvorson will also be able to see both of you, because of the camera's angle. Let's try to get him up. All right. Professor Halvorson, would you like to make yourself seen to us and heard? Ah, there you are. Hello. Could you speak and see if we can hear you here? Would you?
Hi. Good morning.
Excellent. We'll go forward directly then with, we've just watched your video. I don't know if you watched us watching your video, but we watched it. Yes. The fifth wall is going to be torn down eventually. Can you see your two, those who you're responding to? Yes?
Yeah, all
Okay,
good.
okay. Let's go forward then. I will make myself scarce.
I can't really see him though.
Oh, you can't see him.
Unless he sees the back of my head.
Working over you.
I can try to get into the Zoom call, so maybe we can start with
No, it's all right.
Let's start with the question, and I'll try to get my computer into the Zoom call.
You
Yeah?
can see my profile, yes.
Well, do you want to stand here?
Once you shoot that,
Well,
Yeah.
it's connected to everything. I'm
Yeah.
just a little.
Yeah.
Okay. Go ahead. I think I can. It's a discussion first, so
Yeah.
actually, he asked a few questions. If you want to jump in and try to answer them in turn.
Yeah, well, thank you for the response. Firstly, effective laws at each level are what we determine in physics, we determine in the special science. How do we do it? We do it by setting the context so that we can determine the special laws. So it actually, you set up a laboratory, you set up certain apparatus in precisely such a way that you can verify what the laws at those levels are. So there's no paradox between them being affected in the top-down and existence of those laws, because that's what the whole of science does. It's what all of those laboratories, chemistry, biology, microbiology, that's what they're all doing. So I don't think there's a problem there. Now, the Hamiltonian contains two things. It contains a potential in general, and it contains some constraint terms. And those are what describe the context. And so you have to ask yourself always with a Hamiltonian, where does that potential come from? Let's take a very, very simple example, the two-slit experiment. How do you describe that in quantum terms? And you have to have either what you can call it a constraint or a potential, which tells the Schrödinger equation there's a two-slit sitting here. Where did that come from? And it came from the context above. And so one kind of just says to yourself, there's a potential, and I take it for granted, or maybe there's a constraint. But the question is, where did those come from? And they came from the person who set up the experiment in order that it would represent two slits. And so that potential term is not in itself expressible in quantum terms. If you express the potential in quantum terms, you'd end up in an impossible cycle of indeterminacy. And so I personally don't think that there's a problem in that case. Now, a further really interesting point, which I would like to just mention, is quantum field theory. I've talked about creation of elements at the lower levels. And if you ask how does that happen through quantum theory, the answer is it happens through quantum field theory, creation and annihilation operators. If you now look at any textbook on quantum field theory, you'll find a long description of creation and annihilation and what they do, but what you will not find is a statement when does a creation or annihilation operator act. And I've actually I've talked with a couple of people about this who are experts in quantum field theory, and actually the action of the creation and annihilation operations is determined by the higher level context. For instance, I send a photon down onto a photodetector, and that causes the creation operates, or a photon arrives at a leaf or in your eye, and it sets in chain a set of conversions whereby the photon is absorbed, annihilation, and an electron is emitted, and so on. And so I think all of those fit in within the general viewpoint that I'm expressing. And if you ask me what is my definition of causation, I go with the view that definition of causation is difference making, whether counterfactual or experimental. I think that's what I want to say for now.
Can we get Hans to respond to that, or do you want me to do?
Yes, would you like to respond directly to that, Hans?
Yeah, I don't think I have any, so I think my feeling at this point is largely curiosity, because I agree absolutely in principle with, so let me actually give you an example that's maybe a little bit controversial, at least I hope. If there's, I can't see everyone who's there. If there's any convinced Bohemians in the audience, I may get in trouble here, but so I would say, for example, the Bohemians who say, look, our interpretation is great because the observer does nothing in our interpretation, right? The observer is out of the picture, and my reaction to that is, no, not at all, because where does the Hamiltonian come from? And in typical cases, right, it's actually, so I think one problem in these discussions often is when people talk about the observer, they're forgetting, right, the physicist, set aside what's an observer or not, the physicist is the person involved in setting up the experiment and so on. So I completely agree in principle that there is this, the lurking free variable, so to speak, of the Hamiltonian that's involved in all of these interpretations. I would say, I'm not sure yet how strongly we should take that as, so in general, of course, we have this issue that, laws are something that remain unexplained, right? Laws in the typical sort of natural philosophical approach. I know we're now getting already into very controversial territory because on a more Aristotelian approach, we wouldn't want the laws really to be fundamental. In some sense, we want the powers to be fundamental. But in general, people are happy enough to say once we have the laws, those don't need to be explained. Those are just sort of the unexplained explainers. And yet, of course, in the actual practice of quantum theory, we typically are talking about local systems, and local systems where we want to have free parameters we can adjust in the laws. So, like I said, I think I don't really have a strong point to make. I think I'm just largely curious about the role of the Hamiltonian and its free variables, and I think it's really great that Professor Ellis has brought this to our attention in a way much more vivid than it's typically. I think it's typically sort of pushed under the rug, this issue of the Hamiltonian.
I just want to make one further point. So firstly, you have to ask where does the Hamiltonian come from, but prior to that, you have to ask where does the Hilbert space come from. And people are complicated. They just take for granted there's a Hilbert space. Who decided what the Hilbert space is?
Yeah,
That's a great point.
Maybe I should respond briefly. So yeah, Hans, I agree almost everything you said. I guess so. I do make some bold points, but I don't think quite as bold as you attributed to me. So I'm not really claiming that Aristotle provides the only solution to the measurement problem that's possible. Right? I mean, obviously, yes, there are alternatives. And I've tried to, I've written on the many worlds interpretation, trying to criticize that. I think, as you say, there's problems with Bohm. But GRW, sure, that seems like a very viable option. But now let's just look at the situation. Right? We've got now multiple proposals on board now. The one that I'm advocating is, I think, well supported by the actual practice of science. By the way, chemists and thermodynamic scientists actually practice. Whereas GRW is at this point, completely speculative idea for which there's no confirmation. So at the very least, I think, the Aristotelian position should be treated as a serious contender, something that we need to develop and to continue to compare to the other options. And then the point about the infinite system stuff, I appreciate your feedback on that, because I'm very interested in learning more about how this would work. So I think you're right that I don't think I had to claim that the super selection sectors are all macroscopic. All I need to claim is that some of them are macroscopic, right? And then I think I've got enough to make the case that there are fundamental properties at the intermediate level as well.
Yeah, let me just add one. So so not everybody's had the chance. I would encourage them. So Rob, now you have several papers, both completed and in progress, and I think they're a great benefit. And one thing I thought was really wonderful about your papers was the actual incredible intellectual humility you show, saying, that sure, there's resources here. I'm not saying, I noticed repeatedly that you repeatedly said, I'm not saying there's a proof here. I'm saying there's resources here to understand. And I actually think this is one of the most refreshing ideas. So let me say a real point of commonality between your view and something I've recently become more and more convinced of is there's a very strong urge in contemporary analytic metaphysics towards what you might call some kind of actualism. And that includes, of course, David Lewis, the arch anti-actualist. But still, it's strange because Lewis, he still believes everything has to be reduced to what's actual. He just increases the scope of what's actual to all the possible worlds.
Right.
So I think this is one of your most strong claims, but also I'd say I'm increasingly convinced of this. The role of the possible, right? So in other words, saying don't try to eliminate the possible, and I include in that sort of, I would love to hear more about your views on this, but the idea that form is in a certain sense active. I think this is a really fascinating idea. So form is, I think this is common between you and Professor Ellis. Form is explanatory. And so I think that's one of the most, an idea that really would push against an orthodoxy in analytic metaphysics.
Yeah, absolutely. Thanks.
We could at this point open up for broader discussion. We're operating on a 15-minute delay, so we have another 18 minutes. Is that the schedule? I've lost my schedule. Yeah, so we have 18 minutes, right? So we're operating on a 15-minute delay. Yeah, good. All right. So then so we have about 18 minutes for discussion or questions. Yeah, please what I'll do is this. I'll take note of you to put your hand up so that you don't need to compete with one another. We'll start with you, and if you have a small point, I think I got everyone up there. If you have a small point that's on point, you want to jump in and skip the queue, you can do that. But it needs to be quick, like 30 seconds or less, and I'll be the judge of what's 30 seconds. So if I had...
Yeah, John Pemberton.
John Pemberton.
Yeah, great. So thanks, both. I mean, there's so much to ask you, but if I could just focus on one specific point, the downward causation, which George Ellis talks about, which I'm just really interested in how this is, works for you. So
Please speak quite loudly.
Okay, so one question I have, George, is the downward causation you envisage synchronic, or is it a diachronic form of causation? And I guess going with this question is the thought, downward causation is often thought problematic because the whole is then thought to cause change to the parts, whilst the parts are surely causing change to the whole. someone has this concern about self-causation. So I'm just interested in how you overcome those concerns about self-causation.
So is your self-causation?
Yeah, well, is downward causation diachronic or synchronic? Was the
It happens in both. Firstly, it happens in both forms, and secondly, you do get causal circular causation. That's part of what's happening. In fact, that's what I was saying. The thing is only causally complete when you take the whole loop into account. So circular causation, yes, it happens. Yes, it does. An example is the ion channels, where the ion channel opens in response to the voltage, and then the ions flow through, and then they alter the voltage, and then they close the channel. So that's a classic case of.
But that's linear form of causation. That's linear. That could be linear causation.
that could be linear causation?
Non-circular, you're saying.
No, sir. I mean, just one, the ion channel opens, something else happens, you get a transmission down the neuron.
So notice you don't get a cycle of events, right? You get a linear ordering of events at different levels. Is that right?
Yeah.
Well, it's happening across different levels because the ion is a lower level in physical terms than the ion channel, so it's downward causation in that sense. But in time, it's a linear series of events. The channel opens, the current flows, then because the current has flown, the voltage has changed, the channel closes, and that's where those spike chains come from, which occur in our brains. It's where the spike chains come from.
Thank you.
Would you pass it to the fellow there with excellent beard? What's your name?
Paul.
Paul.
Yeah. I have a question for Professor Koons. So the first question you addressed on the cosmic wave function.
What?
The first question about the cosmic wave function.
Yeah.
Such a thing. And you mentioned that in order to make sense of the wave function, we need something like context or a heat bath.
Yeah.
And I was thinking the way an Aristotelian might want to solve this. So Aristotle has these things as potential parts, but what about the contrary, having potential wholes? So some word that is like junky in this way.
Yeah.
And we wouldn't have so it wouldn't make sense to talk about the wave function of the universe because there's no such thing as a universe.
Right.
But you would, for every system, you would have a context.
Yeah.
Or feedback for which, and I wanted to hear what would you think of such proposal?
Yeah, that's a really interesting possibility. Yeah, and so as you all know, the junky world is a world where there are wholes and parts, but no ultimate whole, and the holes encompassed as a proper part of something still larger. So yeah, if there were a junky world, then there'd be no cosmos, and so no cosmic wave function. That's right. And I'm certainly open to that possibility. I think that possibly makes sense. I think what we typically think of as our universe, right, seems to be the sort of thing that is bounded in some way. But of course, it could always be part of some larger whole that we're not aware of. That's true.
Listen. I have Alyssa and then Mateusz, and then I'll go down the line here. Yeah.
I guess I have a lot of questions about the cosmic wave function, but maybe I just was irresistible on the non-locality, and it doesn't matter if you're losing negative powers.
Yeah.
Just if all of a sudden something you did made me not be able to raise my hand or something, what does it matter if I'm gaining or losing? It's still like very puzzling how that could work.
Yeah, I mean, admittedly, there's something sort of counterintuitive about it. The idea that these kinds of power manifestations can be coordinated at a great distance. It seems to me that you're sort of forced to accept that to some extent. I don't know any way around it.
Unless you have the average interpretation.
Well, okay, right. Well, I'd like to hear about that. And that would be good. Because, I mean, in general, Aristotelians like locality. So this is something we have to try to accommodate. But I guess the thought again is epistemologically, it's relevant. So if I can tease out certain causal interactions, and I can be confident that the positive powers that are being exercised are local powers, right? Then I can gain some insight into the essence of the thing involved. Right? Whereas if changes or powers could be acquired, changes occurred by virtue of some completely non-local agent, distant agent, then that creates, I think, a real serious epistemological problem. So I just see an epistemological asymmetry there.
Is this a little one? Okay, after you're done, then please pass it to the first Dominican on your left.
So just to, sometimes part of the explanation of what happens involves things that can't happen, and so losing a dispositional property is like about what can't happen, and that's part of the explanation of what does happen. So I'm not sure I can see the epistemic asymmetry.
Tell us your name. Right.
Oh, Aaron.
I'm Marius.
Good point. I'll think about that.
So that's a question or comment. There is an effect in quantum theory that deals with interaction with the fundamental level, let's say quantum vacuum fluctuations, and the macroscopic bodies. It's called the Casimir effect. Some work in it, William Simpson as well. So do you think it could be useful or interesting to deal with, understand such effects in a way that there we can do like rigorous mathematical quantitative predictions and try to grasp this interaction between the fundamental level and the macroscopic objects, actually without even having the measurement. I mean, the macroscopic body is not involved in the measurement, it just changes the quantum state of the vacuum, and eventually it gives like macroscopic force that attracts all of the plates, let's say. Do you think that this could be interesting for this discussion about the interaction between fundamental level and macroscopic bodies?
The Casimir effect. It's talking about Casimir effect is a good case in which you've got a macroscopic object acting on the quantum vacuum.
Yes, absolutely. I agree. Yeah.
Did you want to comment on it, or you
No,
you affirm?
Yeah.
I agree. I like it.
You can follow up if you want.
No, I will do it here. Or maybe Professor Hans Halvorson wants to add something?
About the Casimir effect? Hans, did you have any thoughts on that?
Okay, hear you.
We don't hear you.
Sorry, I was muted. But are we talking about the same? Is this another name for Rindler Unruh? Is that what you're thinking?
I didn't hear. What?
Is it another name?
Is this the observer in the vacuum with the many particle creation? Is that what you're thinking of the Casimir effect?
No, I'm talking about the vacuum, the quantum vacuum, the electromagnetic field vacuum that interacts with let's say plates. That's the original case for the Casimir. It's not connected with this creating of particles. It's a different effect. You have two plates, let's say, that just in the vacuum they attract each other because of the interaction of the quantum vacuum with the macroscopic bodies.
I can't. It is an example of a top-down effect from the plates to the vacuum. I'd like to add in that, to me, one of the most spectacular effects in quantum physics is the Aharonov-Bohm effect, which is a non-local effect, and it cannot be described in a local way, and I think it's a fantastic example.
That's another, yeah.
So let's do it like this. We're going to just keep passing the microphone. We'll collect them in groups of 3. So if you would ask your question and pass it, and then we'll have the answers. We'll do speed rounds now to get so like speed dating.
My is pretty. I have a rather basic question for both of you about what talk about formal causation amounts to. And we could rephrase it as, what does it mean to say that A is a formal cause of B? Would it, for instance, mean that A is a shape and B is a composite object truly describable as having shape A, and that A synchronically or diachronically determines the type arrangement and interactions of these components? Similar analogous question could be formulated for correct criterion for Professor Koons' account.
You got that?
Are we going to answer?
I think we should compile. We should compile.
Yeah, go ahead. Yeah, I'll remove that. So just a question about what formal causation is exactly. Is shape an example of formal causation?
Yeah, it's shape. Shape is what I would define as formal causation, form and shape. Form is shape, so from my viewpoint.
Yeah, I would think of shape as just one particular kind of form. There's actually many others.
Okay.
Yeah.
But let me just add something. There's a very interesting question. How does quantum chemistry describe the shape of molecules? That's actually quite a difficult question.
This question is for...
Please give us your name, sir.
Okay. Howard Robinson. Yeah. This question is for Professor Ellis. You cited many cases of where there is top-down useful explanations for certain purposes. But what you need to show is that under those circumstances, the bottom level, the atomic, subatomic, is not behaving according to the rules, as it were, that the physicists would say they are, that they're being interfered with in that sense. It wasn't clear whether you thought that they were, or whether if they're not, whether that really makes any difference to the claim that there's completeness under physics.
No, this is a major misunderstanding. I'm not saying that top-down action changes anything at the physics level. What it changes is the context within which those physical laws are acting. If I have Maxwell's equation, I say, tell me what's going to happen as a result of Maxwell's equation. You say, I can't tell you until you give me the context. Maxwell's equations by themselves don't determine anything whatever, nor do Newton's laws. You have to say, what's the context? And that's what a downward causation, or what these things do. So I am not claiming any change in the laws of physics because of downward causation. And that I've been accused of that on various occasions. It's not what I'm claiming. Physics is absolutely the same everywhere in the universe at all times as far as we know.
Does that mean that Laplace's demon, it was a real demon, and it could also allow for the input from outside, would still tell me what everything was doing then? If he could,
So the Laplace's demon at the micro level.
yeah, if he could tell you about, he would tell about the inputs from the context as well, not at the micro level.
So when the Laplacian demon would have access to the context as well as the law, so couldn't it predict everything from the bottom up?
Well, we've been talking about open systems. They have a boundary and it doesn't work for them, as I explained in a lot of detail yesterday. Your brain cannot explain what you are going to do in half an hour's time because other things are going to impinge on your brain from outside. So the Laplacian demon is simply not able, because you're in an open system, to predict what you are going to do in the future. It's not possible.
I mean, if the conditions are not themselves metaphysical, then you haven't established the...
And the example I gave yesterday was a woman driving a motor car, and all of a sudden her car runs into another car. So now her brain has got a whole lot of new information which she did not have before. And if you had total information about what her brain was before the accident, there's no way it can predict what she will do after the accident. So Laplace's demon is it's irrelevant basically with an open system.
But the demon would know also the movement of the cars and everything, yeah?
But then you're just positing God at that point, right?
Right. So I mean, that's just, but in a sense, that's begging the question, I think, against the Aristotelian, right? So you're just saying that the car and its collision and so on is nothing but microparticles. That's what the question.
No, but it isn't. It's how the driver of the car behaves. The whole thing.
If I may, I have
your name.
Question, Chris Oldfield. Hi Hans, thanks for your work as well. I have a question about Schaffer's tiling constraint and the notion of there being non-overlapping individuals in a merological sense of overlapping, but in the same place and at the same time, of categorically different types. So if you have an activity in virtue of which somebody is where its parts are, for example, that's a categorically different type of thing. And I wonder, Hans, if it might relate to your subject-object distinction.
It's a question. There was a question for Hans first. Did you want to answer that?
So it's relating actually to a line in the metaphysics where Aristotle says form is energeia.
Right.
So I'm wondering about activity in the same place as object.
Right.
Whether that would violate the tiling constraint.
Yeah, so the tiling constraint, first of all, does not say that you can't have two things in the same place at the same time, right? It's a constraint on mereology. And so, so I would say, the activity of my activity and me, right, are probably looking in the same place, but they're not. It's not a part of me, I think. And so that wouldn't violate the tiling constraint. Yeah.
Probably a time for one more. Hans was going to answer. No, you were addressing that.
Well, it's got a kind of edge of standpoints of subject and object, because subject can be in the same place as an object in a totally different way. I just wondered what you think.
Yeah, I'm not so sure about that. I guess I think subjects are objects.
He's an objectifier.
Yeah. Yeah.
Would anyone else like to one last question or discussion point?
You know what? Really, no one's getting that.
Tell us who you are.
My name is Ewan. This is because I'd like to ask if I've interpreted this discussion on the class as demon properly, should we see the tendency of the question and the response to the question on the context as pointing, as showing the tendency of microphysical reduction towards a cosmic monism? In other words, towards a cosmic monism, in the sense that yes, you can do microphysical reduction, but because of because of the closed systems which Professor Ellis is pointing, in order to do that, you have to embrace a sort of monistic totalizing account in which one can give an account of all contexts and all parts are referred to one.
Yeah, I guess a question for George is related to that. Maybe if you could answer my question. So in cosmology, if we apply quantum mechanics or something to explain it, there's no context, it seems, in that case, is there? How would you?
Well, I'm personally very skeptical about quantum cosmology for a whole number of reasons. The Wheeler-DeWitt equation, which is usually supposed to underline it, is not a well-defined equation. It was actually rejected by DeWitt. Eventually, he called it that damned equation. The way that solutions are supposed to be obtained for it are very dodgy, and there's not the slightest evidence that the Wheeler-DeWitt equation actually describes anything whatever. So I'm a skeptic.
That pushes against the cosmic monism, I think, in some sense. Yeah.
We'll have to end with that bombshell.